Okay, so we're just going to look at the differences between these five terms. Now, you're going to be using all of these, and you need to use the correct ones when you're asked about it in an exam. So some of them you're familiar with from GCSE, and some of them you have to be quite specific of their use at A-level. So what I'm going to look at is we're going to look two examples. I'm going to look at butane. Now, you know from butane, molecular formula is just simply its formula in full. So it'll be C4H10. Okay. Now, the empirical formula is in the simplest form, the simplest ratio. So we can simply break this down. So C4H10. So in simplest terms, like simplest ratio, okay, that'd be C2H5. All right, and you may wonder what the point of that is, but it will become more apparent once we get later on in the topics when you use empirical formulae. And you may remember thinking about a little bit about empirical formulae when you did work on a mass spectrum, but you'll be coming back to that. Now, these are the two that people mix up quite often. Now, probably you're thinking, I'm going to draw a diagram where we're going to have all the different bonds laid out. That's true, and you may have referred to that as a structural formula until now. Actually, the formulae where you have all the bonds, that is called a displayed formula. So I'm going to draw the displayed formula out here. Okay. And with a displayed formula, you have to show all the bonds in full. So every single bond. There's no shortcuts here, you have to draw the whole thing. Now that's a displayed formula. So what's a structural formula? Doesn't it show the structure? Well, I say in exams you'll be asked to write the structural displayed formulae. If they say displayed, you need to have that. If they say structural, you draw a more simplified version of it. And now what we do is we don't have to draw all the bonds in, but you do have to write out. It's like halfway between this and that. So you write this a formula like this, but it's laid out so that you can understand it. So if we look at that, it'll be CH3, CH2, CH2, CH3. Okay? And what you can do, you may notice that because we have a repeating pattern, that you can simplify this further. You don't have to, but you can. You could say CH3, CH2 twice, because we're just repeating this in the middle, CH3. But you'll see that this should be enough for you to work out that, okay, this formula. Now the skeletal formula is probably the most tricky one that people find to learn, but it's one that you will have to use quite often in exams, especially when the molecules get a bit bigger. Now with the skeletal formulae, you draw a similar formula to this. However, you remove the carbons and all the hydrogens that are attached to the carbons. So this would be simply drawn like this. So you have every end of a line that doesn't have anything on it, and every bend is a carbon. So we have 1, 2, 3, 4 carbons on there. And the hydrogens are not even drawn on, but they would be, you'd have 3 here, 2 there, 2 there, and 3 here. So the 4 bonds on each carbon are present, but you simply don't draw them in. We draw it at a bend like this because you remember for around carbon, you have a tetrahedral shape. So remember, the carbon will have bonds like this around it. So you are representing the 109 degree bond angle in the bend like that on the skeletal formula.